Hello everybody, welcome into another lesson. So today we are going to talk about multiplying and dividing complex numbers. And you're probably familiar with when we did complex numbers in Algebra 2 and earlier in this course of just taking the complex numbers and foiling them or rationalizing the denominator by multiplying by the complex conjugate. Well, what we're going to do for today is we're going to use the trigonometric form of the complex number to perform these operations. So, up first is going to be multiplication of complex numbers. To multiply one complex number times another complex number, you take the first r times the second r, multiply that by the quantity of the cosine of the first theta plus the second theta, plus I times the sine of the quantity of the first theta plus the second theta. And here, for the first example, you have your first complex number is 2 minus 2i. Your second complex number is 1 plus I. We're going to multiply these. So, let's look at z1 here. Well, if we want to find the radius, which is going to be, we'll find r sub 1, that's equal to the square root of your a and b. So that would be the square root of your 2 squared plus negative 2 squared, which is going to end up equaling the square root of 4 plus 4, which is going to equal the square root of 8, which would end up equaling 2 times the square root of 2. So we found r1. Now what about what about theta 1? So we could say the tangent of theta 1 is equal to your b over a, so that would be negative 2 over 2, which would just be negative 1. Well, if we look at the first complex number, you have a positive a and a negative b, so this would put you in the fourth quadrant of the complex plane. So if you take the tangent inverse, if you want to find what angle gives you a tangent of negative 1 in the fourth quadrant, that's going to be based on a 45-degree angle in the fourth quadrant, which would be 315 degrees. So theta sub 1 would equal 315 degrees. Now we need to do the same for z sub 2. So let's find r2. Well, that's going to be equal to the square root of your a squared plus b squared. So the square root of 1 squared plus 1 squared equals the square root of 1 plus 1, which is simply the square root of 2. So r sub 2 is the square root of 2. Now let's go ahead and find theta sub 2. So that's going to be the tangent of theta sub 2 equals your b over a, so that would be 1 over 1, or simply 1. And if you look at your complex number, both your a and your b are positive, so this will be a first quadrant angle. So what angle gives you a tangent of 1 in the first quadrant? That'd be 45 degrees. That means theta sub 2 is going to equal 45 degrees. Alright, so we found both the r values and the theta values for both of these complex numbers. Now we can go ahead and figure out what these are going to be. We can plug in some values here. So in this case, z sub 1 times z sub 2 is going to equal my r1 of 2 times the square root of 2 times my r2, which would be the square root of 2, times the cosine of theta sub 1, which is 315 degrees, plus theta sub 2, which is 45 degrees. All that plus I times the sine of 315 degrees plus 45 degrees, which is going to then equal 2 times the square root of 2 times the square root of 2. That would become 4 times the quantity of the cosine of 360 degrees plus I times the sine of 360 degrees. Now this is just a matter of converting this from trig form back into standard form. So this would just turn into 4 times, okay, what's the cosine of 360? That's just 1 plus I times the sine of 360, which is 0. So you just simply get 4. So the answer you should get for this would be 4. And yeah, we could have just multiplied these and FOILed them and we would have got the exact same thing, but we're trying to show you how to use the trigonometric form of a complex number to perform these operations. I got 2 more multiplication ones, then we'll do some division, because we're also going to teach division of complex numbers today. So let's do a couple more examples of multiplication with these. All right. Let's see. So let's do z sub 1 equals the square root of 3 plus I. Z sub 2 is going to be equal to 1 plus I. Alright, so your first complex number, z sub 1, equals the square root of 3 plus I. Your second complex number, z sub 2, equals 1 plus I. Well, in both cases, the good news is both your A and B's are positive, which means you're going to actually have first angle angles in this case. So let's go ahead here and figure out our R sub 1 from our Z sub 1. So R sub 1, that's going to equal the square root of my A squared, which is the square root of 3 squared, plus my B squared, which would just be 1 squared. Well, that's going to equal then the square root of 3 plus 1, which equals the square root of 4, which equals 2. So my R sub 1 is going to end up being 2. Now let's find theta sub 1. So the tangent of theta sub 1, that's going to equal my B over A, so that'd be 1 over the square root of 3. Well, what angle gives me a tangent of 1 over the square root of 3 in the first quadrant? That's going to be 30, right? So that means theta sub 1 is going to be equal to 30 degrees. All right. Now, let's go ahead and find R sub 2 and theta sub 2. So R sub 2, that's going to equal the square root again of my A squared plus B squared. So that'd be 1 squared plus 1 squared, which would give me the square root of 1 plus 1, or simply the square root of 2. So R sub 2 is the square root of 2. Now let's find theta sub 2. So the tangent of theta sub 2 equals b over a, so that'd be 1 over 1, or just simply 1. Alright, so what angle gives me a tangent of 1 in the first quadrant? That'd be 45 degrees, right? So I'll end up having theta sub 2 would be equal to 45 degrees. Okay, so now we're ready to proceed and find some values here. So that means then z sub 1 times z sub 2 is going to equal my r1 of 2 times my r2 of the square root of 2 times the quantity of the cosine of theta sub 1, which is 30 degrees, plus theta sub 2, which is 45 degrees, plus I times, let's not do that, I times the sine of 30 degrees plus 45 degrees, which would end up equaling 2 times the square root of 2 times the cosine of 75 degrees plus I times the sine of 75 degrees. So that would be the answer in trigonometric form. If we want to convert this into standard form, we're probably going to need to we might have to round a couple decimal places. We're probably going to get a decimal number for this. So, alright, so let's see here. What is the cosine of 75 times the square root of 2 times 2? That would give you about 0.73 plus I. Actually, we'll make the I last since we're going to be converting that sine of 75 times 2 times the square root of 2 into a number. Alright, so we'll take that times the square root of 2 times 2. You get about 2.73 I. So this complex number rounds to approximately 0.73 plus 2.73i. Or if you don't want a decimal answer, you could just simply leave it in the trigonometric form and get 2 times the square root of 2 times the quantity of the cosine of 75 degrees plus I times the sine of 75 degrees. Alright, let's do one more for multiplication, then we'll go on to division. Alright, so let's do z sub 1 equals 2i, z sub 2 equals 1 minus I. Alright, so z sub 1 equals 2i, z sub 2 equals 1 minus I. Let's see what we end up getting here. So first let's find our r1. R sub 1, well, we only have a b coefficient. The square root of 2 squared is just 2. So that's going to be pretty easy. We're just going to end up having 2 for r sub 1. Now let's find theta. So the tangent of theta sub 1 equals, well, that's going to be 2 over 0 because this 2i is really 0 plus 2i. Well, where do we have, this is undefined, okay? Granted, that's true. But where do we get a positive number in the numerator divided by 0 for a tangent? That's going to be at 90 degrees, right? So that means that theta sub 1 would actually have to be equal to 90 degrees. Okay, now let's look at z sub 2, which is 1 minus I. So define r sub 2, you just take the square root of a squared, which would be 1 squared, plus that b squared, which is negative 1 squared. So that's going to equal the square root of 1 plus 1, which would just be the square root of 2. So r sub 2 is going to end up equaling the square root of 2. Alright, now let's find theta sub 2. Theta sub 2, well, that's going to be equal, of course, well, let's say the tangent of theta sub 2 to start with. That would equal at negative 1 over 1, or simply negative 1. Alright, well, if we look at this here, the z sub 2, a is positive, b is negative, that's going to actually put us in the fourth quadrant. So what gives us a tangent, what angle gives us a tangent of negative 1 in the fourth quadrant? It'd be based off of a 45-degree angle in the fourth quadrant, so that'd be 315 degrees. So theta sub 2 is actually going to end up equaling then 315 degrees. Alright, now that we have the r's and the thetas, we can plug this in. So z sub 1 times z sub 2 is going to equal your r1, which is 2, times your r2, which is the square root of 2, times the quantity of the cosine of 90 degrees plus 315 degrees plus I times the sine of 90 degrees plus 315 degrees, which is going to end up equaling 2 times the square root of 2 times the cosine of 405 degrees plus I times the sine of 405 degrees. Well, there is a simpler way to convert this. 405 is past 360, so if you subtract 360 from 405, that would give you just 45. So you would end up getting 2 times the square root of 2 times the cosine of 45 degrees plus I times the sine of 45 degrees. So there's your number in trig form, but let's convert this to standard form. This would be equal to 2 times the square root of 2 times, what's the cosine of 45? That's just 1 over the square root of 2 plus I times the sine of 45 actually also happens to be 1 over the square root of 2, which would just end up giving you 2 plus 2i. So you should end up getting 2 plus 2i as your number in complex form, in the standard form of the complex number. Alright, so that's multiplication of complex numbers, let's do some division now. So let's go ahead here. I'm going to write the formula for division. And the division formula is only slightly different. So I'll show you how here in just a second. Well, I could have left the plus there. Yeah, that'd be minus. Let's change this to reflect what we're really doing. All right. So if you're going to divide two complex numbers, it's the same thing as the first r divided by the second r times the quantity of the cosine of theta 1 minus theta 2 plus I times the sine of theta 1 minus theta 2. So it's a little bit different for dividing complex numbers. So let's say here, let me go back to the page. All right. So we're given z sub 1 equals 3 plus 3i divided by z sub 2, which is going to be 1 minus I times the square root of 3. So we're going to divide these two complex numbers. Well, first thing, just like we need to do with multiplication, is find your r's and thetas for each of these. So for z sub 1, of course, we'll find r sub 1, which is going to be the square root of that 3 squared plus 3 squared, which would be the square root of 9 plus 9, which is going to equal the square root of 18, or simply 3 times the square root of 2. Now let's find theta sub 1. Alright, so you're going to go based off of z sub 1, so the tangent of theta sub 1 is going to equal, of course, 3 over 3, which is just 1. And if you notice for z sub 1, both your a and b are positive, so you'll be in the first quadrant. What angle gives you a tangent of 1 in the first quadrant? That would just be 45 degrees, right? So the theta sub 1 would be equal to 45 degrees. Okay. Now let's deal with r sub 2 and theta sub 2. So r sub 2 is going to be equal, of course, to that square root of 1 squared plus that negative square root of 3 squared. So that's going to equal the square root of 1 plus 3, which is the square root of 4, which just equals 2. So we found r sub 2 to be 2. Now let's find theta sub 2. So let's start out with the tangent of theta sub 2 equals your b over a, so that'd be negative square root of 3 over 1, or simply negative square root of 3. Well, okay, so here's the thing now. Your a is positive, your b is negative, meaning you're in the fourth quadrant. What angle gives you a negative square root of 3 tangent? That's based off of a 60-degree angle in the fourth quadrant, which would be 300 degrees. So theta sub 2 would be equal to 300 degrees. Alright, so now we found our r sub 1 and r sub 2, and our theta sub 1 and theta sub 2. We're ready to do all this. So to find the division of these complex numbers, z sub 1 equals z sub 2, that's going to equal your r sub 1, which is 3 times the square root of 2, all over r sub 2, which is 2, times the cosine of that theta sub 1, which is 45 degrees, minus your theta sub 2, which is 300 degrees, plus I times the sine of 45 degrees minus 300 degrees. So there's you starting out with your trig form. So this would still be 3 times the square root of 2 all over 2 times the cosine of, all right, so 45 minus 300, that'd be negative 255 degrees. Plus I times the sine of negative 255 degrees. Well, we have even and odd properties for functions. This would actually turn into 3 times the square root of 2 over 2. Well, the cosine of a negative angle is the same as the cosine of the positive of that angle. So this would be the cosine of 255 degrees. And then the sine of a negative angle is the negative of the sine of the positive angle. So that'd be minus I times the sine of 255 degrees. And if you wanted it in trig form, you could leave it that way. You'd end up getting 3 times the square root of 2 over 2 times the cosine of 255 degrees minus I times the sine of 255 degrees. But we're going to actually go for decimal approximation. So let's see what we get here for the cosine of 255 degrees. Take that times the square root of 2 times 3. Now divide that by 2. You get about negative 0.55 for that first number. And then let's take the sine of 255 degrees. So negative of the sine of that, I should say. All right, times the square root of 2 times 3, divide that by 2, you get about plus 2.05 I. So if you round to 2 decimal places for each component, your number in standard form is approximately negative 0.55 plus 2.05 I. And I got 2 more of these. Alright, z sub 1 just equals 5 all over 2 plus 2i. So we have 5 divided by 2 plus 2i. Well, let's start out finding r sub 1. Well, that one should be pretty easy because you just have an a, you take the square root of a squared, you just get a. So the square root of 5 squared is simply 5. So r sub 1 is just simply going to be 5. Okay. Now, let's find theta sub 1. So the tangent of theta sub 1, well, the real form of 5 is 5 plus 0i, so this would simply be the tangent of theta sub 1 equals 0. Well, if you have a positive number plus a 0, that's usually denoting that it's on the positive x-axis, which would favor the first quadrant. So theta sub 1 is actually going to be 0 degrees. So theta sub 1 is actually 0 degrees. Okay, now what about r sub 2 and theta sub 2? So r sub 2 would equal the square root of that a squared, which would be 2 squared, plus your b squared, that's another 2 squared. So that's going to equal the square root of 4 plus 4, which is the square root of 8, which would equal 2 times the square root of 2. Alright, so r sub 2 equals 2 times the square root of 2. Now, let's figure out theta sub 2. So, the tangent of theta sub 2, that's going to equal b over a, so that'd be 2 over 2, which equals 1. Well, it looks like z sub 2 is in the first quadrant because both a and b are positive, so that means theta sub 2 should be 45 degrees. Alright, so we know both r's and both thetas now. Now we may proceed to finding these numbers. So z sub 1 divided by z sub 2 is going to equal my r sub 1, which is 5, all over my r sub 2, which is 2 times the square root of 2, times the quantity of my cosine of theta sub 1, which is 0 degrees, minus my theta sub 2, which is 45 degrees, plus I times the sine of 0 degrees minus 45 degrees So this is going to turn into 5 over 2 times the square root of 2 times the cosine of negative 45 degrees plus I times the sine of negative 45 degrees. Okay, well, let's use the even and odd function properties. Cosine of a negative angle is the same as the cosine of the positive of that angle. So that'd be 5 over 2 times the square root of 2 times the cosine of 45 degrees. And then sine of a negative angle, again, is negative of the sine of that positive angle. So this would be minus I times the sine of 45 degrees. Which is going to turn into 5 over 2 times the square root of 2 times what is the cosine of 45 degrees? Well, that's 1 over the square root of 2. Then sine of 45 is also 1 over the square root of 2, so that'd be minus I all over the square root of 2. Which, when you multiply all this, there's a reason I didn't rationalize yet, because if you don't rationalize, you'll be able to cancel out the radicals right from the denominator. So when you multiply this, you should end up getting 5/4 minus 5/4 I. So it actually worked out nicely not rationalized in the denominator. So in the end, you should get 5/4 minus 5/4 I for your answer. And I got just one more, then we're done with the lesson. All right. Alright, so z sub 1 equals 4i. Z sub 2 is going to be equal to negative 1 plus I. So we're dividing two complex numbers again. While z sub 1 equals 4i, z sub 2 equals negative 1 plus I. Well, let's go ahead and find our r's and our thetas. Well, r sub 1, we only have a b because this is really 0 plus 4i, so the square root of 4 squared is simply 4, so your r1 is 4. Now what about theta sub 1? So that means the tangent of theta sub 1 is going to equal 4 divided by 0, which yes is undefined. However, when you have a positive number divided by 0, that's going to be a 90-degree angle, right? So that means theta sub 1 is actually going to be equal to 90 degrees. Okay, let's go for r sub 2 now. R sub 2, that's going to be the square root of that negative 1 squared plus the 1 squared. So that's going to equal the square root of 1 plus 1, or simply the square root of 2. So r sub 2 is going to equal the square root of 2. Now let's find theta sub 2. So the tangent of theta sub 2, that's going to be equal to your b over a, which would be 1 over negative 1, or simply negative 1. Now notice, your a is negative, but your b is positive. This is actually going to be in the second quadrant. You'll actually be put in the second quadrant this time. So, what gives you a tangent of negative 1 in the second quadrant? This will be based off of a 45-degree angle in the second quadrant, which would be 135 degrees. So theta sub 2 is equal to 135 degrees. Alright, so we know our r's, we also know our thetas. We have enough now to go ahead and divide these. So z sub 1 divided by z sub 2 equals my r1, which is 4, over my r2, which is the square root of 2, times the quantity of the cosine of theta sub 1, which is 90 degrees, minus theta sub 2, which is 135 degrees, plus I times the sine of 90 degrees minus 135 degrees. Okay, well, let's simplify a bit further. So you'll still have 4 over the square root of 2 times, this would turn into the cosine of negative 45 degrees plus I times the sine of negative 45 degrees, which would end up equaling 4 over the square root of 2 times the cosine of positive 45 degrees minus I times the sine of 45 degrees. And we can make this into standard form by simply taking the cosine and sine of 45 degrees. So this would equal 4 over the square root of 2 times the cosine of 45 is, well, the square root, it's going to actually be, let's write it as 1 over the square root of 2. Minus the sine of 45, well, that'd be I times 1 over the square root of 2, which in its final form should end up giving you 2 minus 2i. So in its final form, you should just end up getting 2 minus 2i. Now, I know today's lesson seemed like a lot more work than necessary, and in truth, it probably was. You're better off to just multiply your denominator by your complex conjugate and solve it that way. It's usually a lot easier. But I still gotta teach you how to use trigonometric form because it's very important you know how to do that. Now, the next lesson, we're going to take complex numbers and raise them to powers and even take roots of them. That's where you're going to be glad to have some of the formulas we have for trigonometric numbers and for complex numbers in trigonometric form. We're going to get something called de Moivre's theorem, which helps us to be able to raise trigonometric numbers or complex numbers to powers using the trigonometric form, as opposed to taking that number and using the binomial theorem, which could really be awful. So I hope everyone has a great day. Take care.